Hi folks, this is the third lesson in the Adding Fractions with Different Denominators series. So unless you feel very comfortable doing this work with fraction pieces, and you feel very comfortable, or at least medium comfortable, moderately comfortable, doing this work the graph paper way, like this, you should not move on to this yet. This is a reminder lesson for the people who have already had this and just need a review of how to do it. So let's look at this one. We have 1/3 plus 1/6, and they have different denominators. They have different bottom numbers of their fraction. We need to find a way to make them both have the same denominator so that we can add them together. So just like in the versions where you use the materials or the graph paper, you're going to first ask yourself, is it possible to turn my thirds into sixths? You always want to ask yourself the piece that is bigger. A third is a larger piece, so ask yourself if you could cut it up and make it into sixths. If you have practiced enough with fractions, you should know that yes, that is possible, because a third is the same as 2/6. If you haven't practiced enough with fractions, one way to find this out is to ask, is 6 a multiple of 3? If I count by threes, will I ever say the number 6? Well, if you count by threes, you say 3, 6, so clearly you would. That means that we only have to change this one. 1/3 is the same as 2/6. So the 1/3 changes to 2/6, and the plus 1/6 stays the same. Now it's simple addition. 2 plus 1 equals 3, and they are sixths. Once you've done this, you can reduce. 3/6 is the same as 1/2. This is something that you should have practiced fractions enough that your brain tells you that. If it doesn't, that means that you need more practice. The other thing you can do if you're trying to reduce a number, if you're trying to turn 3/6 into 1/2 and your brain doesn't automatically know that those are equivalent, is you can ask yourself, is there a number that I can divide both 3 and 6 by and come out perfectly even with no remainders? Well, 3 is divisible by 3 and 6 is divisible by 3. If you divide 3 by 3, 3 divided by 3 equals 1. If you divide 6 by 3, 6 divided by 3 equals 2. That's kind of a way to get around it if you haven't practiced your fractions work enough. But ideally, you should keep practicing. Let's try some more. Okay, let's try this one. This one is going to be the same style as this, where we only have to change 1. So if you want to challenge yourself or see if you're getting it, pause right now and go try this one. We're going to do 1/2 plus 1/6. Okay, pause and go try that if you think you can. And then let's do it together. All right, can I break a half into sixths? What I'm asking myself is, can this piece be broken evenly into sixths? It can, both because I've practiced with my fraction pieces and can picture it, but also because if I count by twos, I will eventually get to 6. 2 is a factor of 6. 6 is a multiple of 2. 2, 4, 6. All right. Now, it takes 3 counting by twos to get to 6. 2, 4, 6. So if I want to turn 2 into a 6, I multiply it by 3. If you do something to the denominators, you have to do it to the numerators too. So that means we're going to do times 3 to both of these. If I say 1 times 3, I get 3. If I say 2 times 3, I get 6. That means that 1/2 is the same as 3/6. Now we can add our other sixth back in. 3/6 plus 1/6 equals 4/6. Wow, that was a very tiny, very sloppy 6 I did. I'm going to rewrite it here. 4/6. Now let's see if we can reduce it. My brain tells me we can already, but if it doesn't, let's try that question we asked ourselves over here. Is there a number that both 4 and 6 can be divided by? Well, we could divide them both by 2. 4 divided by 2 equals 2. 6 divided by 2 equals 3. So that means that 4/6 is equivalent to 2/3. It's the same as 2/3. All right, let's try another one. If you're feeling good and want to stop right now, you totally can. But if you're not getting it, I'm going to keep doing a few more for some examples. So let's try this one. Let's try 1/4 plus 1/3. All right, can I take thirds and break them into fourths? I can't. Here we need to do something new. We need to find a number that I can turn both fourths and thirds into. This is where having practiced that common multiples work is going to be really, really helpful. If you don't remember what common multiples are, there's already a lesson posted on it, and it would be a really good choice for you to go practice that. A common multiple is a number that I will say when I count by 4s and will say it when I count by 3s. So if I say 3, 6, 9, 12, 12 is a multiple of 3, and 4, 8, 12. 12 is a multiple of 4. So we're going to change these into twelfths. There are a couple different ways of looking at this. One way is to break each part apart separately and try it like this. We're going to do that way first. So down here, we're going to rewrite 1/4. And we're going to ask ourselves, what do we have to multiply it by in order to turn it into twelfths? We know we want twelfths. So we're going to say 4 times what equals 12. This is like that early algebra work that some of you have been doing. 4 times something is 12. 3. 3 is the answer there. Times 3. 4 times 3 is 12. Because we know that there's a times 3 right here, we have to know that that goes on the top too. Then we can say 1 times 3 equals 3. 1/4 is exactly the same thing as 3/12. Twelfths. I'm going to switch and make the thirds work in purple just so you can see them separately. All right, so let's do that over here. We'll rewrite it. 1/3 times something equals twelfths. We decided using our common multiples knowledge that twelfths is what we needed. So now we just have to figure out how to get there. 3 times something equals 12. Well, let's count. 3, 6, 9, 12. It takes 4. 3 times 4 equals 12. 3 times 4 is 12. Yep, that checks. So then we'll put times 4 up here also. 1 times 4 is 4. So this means that now we can rewrite our entire question and actually answer it. So 1/4 turned into 3/12, and 1/3 changed into 4/12, and now we can add them together. 3/12 plus 4/12 equals 7/12. Now let's ask ourselves, can we reduce this? Well, is there any number that 7 and 12 are both divisible by? Really easy answer. 7's a prime number. That means that 7 is only divisible by itself and 1. So can 12 be divided by 7? It can't, so that means this is as reduced as it can go. Here is your answer, 7/12. If your parents look at this work and say, hey, I know a trick for that work, see if you can figure out the trick on your own instead of having them show it to you. If you can figure out the trick on your own, it will stay in your brain better, and it will be a way that you can test yourself to find out if you really get this work. Try to resist having them give you the trick, because it's not going to result in a really good understanding in the long term. You're better off practicing it till you discover the trick on your own. If you could hear him, Cricket said hi. I would consider this a good end place. If you feel good, go ahead and turn this video off right now. But if you're feeling like you need to see it a few more times, this is a work that for most people, it takes a lot of repeating until it makes sense. So I'm going to turn the page and do a bit more of this. If you feel like you want to keep listening, go for it. This would also be a good way to work along with me a couple times by pressing pause right before I start a question, solving it, and then turning it back on so we can do it together. So let's try this one. Let's try 1/5 plus 1/3. First question is, can I break thirds into fifths? I can't, so that means I need to find my common multiple. Common multiple. That means what's a number that I can get to when I count by 5s and when I count by 3s. And I want it to be the lowest common multiple, the first one we come to. So if you need to pause, go ahead and pause now and give this a try. I know that counting by 5s and counting by 3s, I will say 15 both of those times. The common multiple, the lowest common multiple of 5 and 3 is 15, which means I'm going to turn both of these into 15ths. So let's write our two separate questions. We have 1/5 times our unknown thing equals 15ths, and we have 1/3 times our unknown thing equals 15ths. All right, let's figure it out. 5 times something equals 15. 5, 10, 15, 3. Whenever you change something in the denominator, you need to change it the same way in the numerator. That will make it so that your numbers stay equivalent. If you want 1/5 to turn into a proper number of 15ths, you need to do the same times 3 to the denominator and to the numerator. 1 times 3 is 3, so 1/5 is the same as 3/15ths. Let's move down here. 1/3 times something will get us to 15ths. 3 times something equals 15. 3, 6, 9, 12, 15. It took 5, so times 5. 3 times 5 is 15. All right, do the same thing to the numerator, the top half. 1 times 5 equals 5, so 1/3 is the same as 5/15ths. Now I can add these together. 3/15ths plus 5/15ths equals 3 plus 5 is 8, equals 8/15ths. Now, can we reduce it? Well, is there a number that both 8 and 15 are divisible by, can be divided by properly? Let's see. 8 can be divided by 2 or 4 or 8. 15 is not divisible by 2 or 4 or 8, so it is as reduced as it can be. If we cannot reduce it, the answer is 8/15ths. So come all the way back here to the question. 8/15ths. There is a lot of work put into solving just one question like this, which is awesome. It means that you are getting a lot of practice in a lot of different areas. Being able to do this is relying on your practice of early fractions work. It's relying on your common multiples knowledge, so your ability to skip count and your memory for figuring these out. It's relying on your early algebra by being able to say 5 times something equals 15. What is that something? It's relying on all of that together. So if you're struggling with this work, think about those 3 things. Figure out which one you haven't practiced enough. Have you practiced your skip counting and can you find common multiples easily? Have you practiced the earlier work with fractions, like where you add ones that have the same denominator? And have you practiced the early algebra, the 5 times something equals 15 questions? Figure out which of those you need to practice if you're struggling and go practice. And then let me know if you're struggling still and we can work together on it. Bye for now. Give this a try. You can probably do it. Have a good day.